Hey everyone. So we're wrapping up our integer operations unit here. Uh, I'm skipping through 2.1 and 2.2 for the sole reason that we went over it in class. Now, for those of you who weren't there, I'm going to quickly review it before moving on to 2.3. So, really quickly, I'm going to do a couple of practice problems. Let's start with addition, right? So for both addition and for subtraction, we have to kind of put into account, one second here. We have to put into account a bunch of things. First of all, I always split up my addition and subtraction problems into three parts. This is where you start on a number line. So this would be the number on the farthest left. And then you're either going to be addition, subtraction, whatever your operation, right? And this will be your operation. Oh, actually, let me type it out so it'll look a little better. This is your operation and your sign. And then you're going to have whatever number is on the right. So let's see how this works together. Let's say we have -3 plus -4. Yeah? So here we have -3 plus -4. And what I mean by start here is, first of all, we need to create our number line. So if we create our number line, it'll look something like this. And our start, we start with -3 on our number line. So you can put -3 on your number line, and this is your starting point. Now, for your operation sign, this tells you which direction to go. For those of you who might remember, I always like to use this little chart here, and it really helps to have it next to you when you're doing these problems. It makes things easier to remember. If you're adding a negative number, you're going, oh, sorry, actually, you should go to the left. There we go. If you're adding a negative number, you should go to the left. And if you're minusing a positive number, you should also go to the left. If you're adding a positive number, you should go to the right. And if you're minusing a negative number, you should go to the right. So you see here, same signs, you go to the right. Different signs, you're going to the left. In this case, I'm going left because I'm adding a negative number. And how many times I'm going to be moving is this one right here, 4. So I start at -3. I know I'm going left. How many times? 4 times. So I start here, 1, 2, 3, 4. And on the number line, this would go -4, -5, -6, -7. So the answer to that is -7. Okay, let's try another one. So I'm going to erase this. Again, if I'm going a little bit too quickly, you can always replay this, watch it over again, and you can pause at any point if you need to take notes. So I'm going to take these away. I'm going to leave this because this is really important to have on the side. So let's say that we have -5 minus -6. All right. So right here, this is our starting point. So we are starting on -5. Again, if you're at the point where you're confident with this, you no longer need the number line, that's great. You don't have to use the number line when you're showing your work. But this is really good training wheels for those students who are having a difficulty with it. And just like training wheels, after a little while, you can take them off. You can stop using it after you feel comfortable. But until then, this is really good to do. So I'm starting with -5. My direction is -. So again, I'm looking at my chart. -, I'm going to the right. How many times? 6 times. So I'm going to go 1, 2, 3, 4, 5, 6 to the right. So it's -5, -4, -3, -2, -1, 0, 1. So the answer to this is +1. All right. Now let's say we had a addition problem. So let me do this real quick. Let me cut that out. So let's say we had 14 plus -20. Oh, I don't want to do 20. Let's do -2. Yep. So here, again, same thing. We started with this. So we're going to make our number line. We started with 14. We are going to the, well, let's see, that's a plus negative. So plus negative is on top here. That's going to be left 2 times. So 1, 2. On a number line, that's 13, 12. So the answer to this is 12. Okay, that's a quick little review. Again, if you want me to do more practice problems with this, please just ask me in class. You can private message me. That's completely fine. And I'll do a couple of these in class until you feel comfortable with it. But that's it for today for this video. I have another video on how to do this on the YouTube channel as well. You can watch that as well if you'd like me to do a few more problems. But that's all I'm going to do for today on this one. So, and then another recap on multiplication and division. Okay, so for multiplication and division, a couple things to know. If you're multiplying same sign, so let's say you have a positive times a positive or a negative times a negative, it's always going to come out positive. It doesn't matter. Okay, in terms of the sign, it's always positive. Now, if you're multiplying different signs, so let's say one's a positive and negative, or flip it even, negative, positive, it's always going to come out negative. Okay? The same kind of thing works for division. So here, if, let's pick purple. If I did a positive divided by a negative, okay, this is a division bar. If you didn't know that, please remember that this is a division bar. Let me write a little note here. That means division. So whenever you see that, you should automatically think, okay, division. You might think it's a fraction sign, which you're completely right also. Fraction is a division problem. That's why you can turn it from a fraction to a decimal by using division. So when you see this, that means division. So if I have a positive divided by a negative, or if I have a negative divided by a positive, both of these will equal negative. Okay, different signs, just like up here, different signs, negative. If they're the same sign, positive divided by positive, or a negative divided by a negative, these equal positive. So again, same signs, positive. Different signs, negative. Now, how does this come into play when you're working things out? Well, first I'm going to put these a little bit to the side because I'm not going to be using them at the moment. I'll put them over there. Yep. Okay, so let's see a couple problems here. Let's do this one. So here, well, that's division. Let's do multiplication first. So here, let's say we have -7 times -7, right here. So all you're really going to do is you're going to multiply them as if they didn't have those signs. So 7 times 7 is 49, right? And then you're going to apply the sign. So first step, so the steps first is multiply or divide without caring about signs. That's step 1. You don't really care about the signs at first. They don't matter right now. Step 2 is to then apply the signs based off your rules. So step 1, I'm going to multiply them as if there was no signs. I don't really care about the signs right now. So that's step 1. Step 2 is to then figure out, okay, now am I going to say is it positive or negative? Well, they're the same sign. They're negative, negative, so that means that this is a positive 49. No, you do not need to put the positive sign there. That's just for me to show you that that's positive. So here, let's try again. Let's say -15 times 9. Okay, -15 times 9 is, I'm just going to multiply them like normal. I'm going to pretend that there's no sign. I'm going to kind of ignore it. 9 times 5 is 45. 9 times 1 is 9, plus 4 is 13. So this is 135. And now I apply the signs. One's a negative, one's a positive. Well, according to my chart, that means that this should be a negative. So it's negative 135. Let's do a couple more. Let's say negative 6 times, let's do a positive negative. 14 times negative 2. So let's say we have 14 times negative 2. Okay, 14 times 2, 28. Is it positive or negative? Well, one's a positive, one's a negative. So that's going to be a negative. Yeah? So as long as it's the same thing every time, there's nothing really different about it. You're just going to multiply or divide as if you're not caring about the signs. Then at the end, you apply the signs based off of your rules. Again, just like the chart with the left and right, you should also have this next to it. It's really useful until you memorize it and you can do it without looking. But for now, like training wheels, they're really good to have. So that's multiplication. Division is exactly the same thing, except, well, you're dividing. So here, let's say we have, I don't know, this one. 21 divided by negative 3. Okay, I'm just going to divide as if I don't care about the signs, because right now I really don't. 21 divided by 3 is 7. And then because I will move my division rules now to here. There we go. So according to my division rules, a positive divided by a negative, positive divided by negative, is negative. So that means that my answer here is negative. Okay, what about negative 11 divided by, or let me put that, negative 11 divided by negative 1, because that's what it says here. Well, 11 divided by 1 is 11. And then it's a negative on top and a negative on bottom. Negative divided by negative is a positive, so that's a positive 11. Okay, let's try 0 divided by negative 7. Well, 0 divided by negative 7 is 0. Now, 0 doesn't have a sign. There's no such thing as positive or negative 0, so step 2 doesn't really apply here. You just put 0. Now, negative 6 divided by 0. This will give you an error on your calculator. So you can put no solution, impossible, whatever, no answer. And the reason being, you cannot cut something into nothing. This is pretty much what you're saying. I want 21 divided into 3 pieces. Well, that means I'll have 7 of them, okay? Or 21 slices of pizza divided by 3 people. That'll give me 7 slices per person. I don't know who's eating 7 slices, but if they wanted to, they can have it. If I had like $11 and I was dividing it by $1 a person, I could give it to 11 people. If I had 0 zebras and I wanted to split it among 7 people, they all get 0 zebras because I only have 0 zebras. If I had 6 cookies and I wanted to split it among 0 people, you can't split cookies or anything into nothing. It's impossible. So it's an error. No solution, no answer, impossible. You're crazy. What are you doing? Any one of those things, fine. So if you have any questions about this or anything up here, just ask me during class again. This was just a quick review before I move on to the next portion. So move that over here where no one can see it. Awesome. So 2.3, applying integer operations. So one of the biggest things here to remember for integer operations is your PEMDAS. Now, I'm not a really big fan of using PEMDAS. I actually like using GEMS, and I'll teach you both of them. And it's up to you which one you want to use. It's honestly the same thing. It's just that PEMDAS is a little misleading. For example, PEMDAS. P stands for parenthesis. parenthesis. And then exponent, multiply, divide, addition, and subtraction. So this kind of tells you the order of operations. What they don't really tell you is that multiply and divide should actually have the same level of priority. Addition and subtraction should also have the same level of priority. The only reason you should choose addition over subtraction or subtraction over addition is because you always want to go from left to right. So whatever on the left is going to go first. Whatever's on the right is going to go second. So now I'm going to show you what gems means. I like gems because it already kind of shows you that they're on the same level. So for example, G stands for grouping symbol. So a grouping symbol, that can be like parenthesis, it can be braces, it can be brackets, even a division bar. Division bar also counts as a grouping symbol. And you'll see that later on this year, that it is a grouping symbol. It groups things together. So that's all it stands for. Parenthesis only means this little thing here, but actually it should be all of these also. So next, also still exponent. That's the same. This is multiply, divide. So they're on the same step because they should be on the same step. They should be done at the same time depending on what's left and what's right. And then last is subtract, add. So you can use PEMDAS, you can use GEMS, whichever one you're comfortable with. If this is easier for you to understand, go for it. If this is easier for you to understand, also go for it. I'm not going to take away points on which one you use. Just use one of them. Okay? They pretty much say the same thing. It just depends on how you're thinking about it. Just remember, if you're using PEMDAS, multiply and divide, it only matters what's on the left. That goes first. Add, subtract, it matters what's on the left. Okay. Now, what do I mean by that? Reggie lost 3 spaceships in a level 3 of a video game. He lost 30 points for each spaceship. When he completed level 3, he earned a bonus of 200 points. How much did his score change? All right. That was a lot of information. Let's try and keep track of it. He lost 3 spaceships in level 3 of a video game. He lost 30 points for each spaceship. All right. So if he lost 3 spaceships, and every time he lost a spaceship, he lost 30 points, well, then I would probably write it as 3 times negative 30 points per spaceship. Yeah? The reason why you would want to use multiplication here is because you're doing subtraction or addition multiple times. There is no difference between negative 30, minus 30, minus 30, between this and this. There is no difference, except this one requires less writing. So if you'd like to do this, go for it, but this is a little bit cleaner, all right? And eventually this is kind of what's expected as you move up in math. So we're gonna kind of take this away because it's taking up a lot of space. But when he completed level 3, he earned a bonus of 200 points. So by the end of level 3, he gained 200. So gained, he earned, he went bigger, he grew. These are all addition words. He earned 200 points at the end of his game. All right. So here we go. Based off this, I'm going to use gems just to kind of show you what it looks like. Grouping symbols. All right. So first thing it says is to look at my grouping symbols. I have a grouping symbol in here. Pretty much this is just saying if there's anything you can do inside of here, do it first. There's nothing really to do inside of here because it's already done. So we move on. Next, exponent. There's no exponents. Multiply, divide. All right. I'm going to multiply this. So what is that? 3 times negative 30. So 3 times 30 is 90. This is a positive. This is a negative. So different signs means negative. If you forgot already and you don't have it in your notes, rewind this video and put it in your notes, then come back to this point because I'm not going to write it out. I'm expecting for you to have it in your notes already. So negative 90 plus 200. I haven't done anything with that yet. Now, multiply, divide is done. Subtract, add. Okay, so negative 90 plus 200. I'm starting with negative 90. Or actually, I should probably put this a little bit closer. Negative 90. I'm adding a positive number, which means I'm going to the right 200 times. Now, it would be very, very tiring to go to the right all 200 times. So I'm kind of just jump by 100s. So I'm going to go 100 to the right. So if I was at negative 90, then I move to the right 100 times, I should be at positive 10. You could slow count it all the way, go for it. You can go by 10s, whichever you're comfortable with. I just chose 100s because it's easy to do for me. So we went plus 100 here. We went 100 to the right. We're going to do another 100 to the right. And now we're at 110. So the answer to this is 110. Okay, we'll do another one. Here, they kind of already gave us the expression. So negative 6 times 13 minus 21. So negative 6 times 13 minus 21. We'll do this one now. Parenthesis, again, there's nothing really to do inside this parenthesis. It's already pretty much finished. There's no exponent. There is a multiply. There's a multiply, but no divide. So negative 6 times 13, I believe that is 78. Okay, so 78. One's a negative, one's a positive, so that becomes negative. Minus 21. Okay. So now I'm going to do negative 78 minus 21. So let's work it out. I start at negative 78. I'm minusing a positive number. So I'm going to the left 21 times. Again, I don't really want to do 21, so I'm going to go by 10s. So negative 78, I'm going to move to the left 10 times. So now I'm at negative 68. I'm going to go one more time to 10. So that's negative... Oh, wait, no, that shouldn't be a 68. That should be an 88. What am I doing? Almost made a grave error. So that should be an 88. And then this would be a negative 98. And then 20, 10, 20. I still have one more, so I'm going to go over 1. And that is negative 99. So the answer here is negative 99. If it's starting to make sense to you, awesome. If it doesn't, don't worry about it. We will go over it in class. But I'm going to keep doing a couple more. I'm going to finish these your turns. So let's see. Let's move this. All right. So we have negative 12 divided by 6 plus 2. All right. Grouping symbols. Nothing really to do inside here. Exponents. There are none. Multiply, divide. Okay, there's no multiplying, but there is division. So negative 12 divided by 6. 12 divided by 6 is 2. One's a negative, one's a positive, which means it's a negative 2 plus 2. For this one, you have to remember a little bit of vocabulary. For those of you who remember, awesome, this is called an additive inverse, which pretty much means that they're the same number, but one's positive and one's negative, they're different signs, which means when they add together, you just get a 0. So which means the answer to this is 0. So vocabulary, knowing vocabulary can be very easy. It's a lot of hard work in the beginning, but if you really commit it to memory, it'll make things so much easier for you. Okay. So let's do this one. Negative 87 divided by negative 3 minus 9. All right. So we got negative 7 minus, oh no, that should be divided by negative 3. So parenthesis, nothing to do here. Exponent, there are none. Multiply, divide, okay, there's no multiplication, but there is division. So I'm going to deal with that. So negative 87 divided by negative 3. Where's my, okay. 87 divided by 3. So 8 divided by 3 goes into 8 2 times. 3 goes into 27 9 times. So the answer here is 29. They're both negative, which means it will come out positive. Minus 9. Okay. Let's make our number line. So we're at 29. I'm minusing a positive, which means I'm going left 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 29, 28, 27, 26, 25, 24, 23, 22, 21, 20. So the answer is 20. Okay, number 6. So we have 40 divided by negative 5 plus 30. Cool. So 40 divided by negative 5. I'm not going to be talking about this in the next couple because we kind of got the idea already. But if you need me to go over it again, ask me in class, or you can rewind to the previous ones and see how it worked. So 40 divided by negative 5 is 8. Negative 8 plus 30. And then I started at negative 8. I'm going to the right 30 times, which comes out to, pause it right now to work it out. I'm not going to work it out with you. Okay, it comes out to 22. And again, if you need more help with this, ask. I'm going a little bit more quickly, just going through the steps and not exactly the solving. And then here we have negative 39 divided by 3 minus 15. So here, negative 39 divided by 3, what is that, like 13? Negative minus 15. So start with 13, move to the left 15 times. That comes out to negative 28. All right? All right. And now we have to circle the expression with the greater value. Okay, so if you're comparing, we're going to be using some symbols. If you forgot them, I'm going to write them out right now. We have greater than, so this is greater than. You have less than, less than. You already know equal. Right? I'm not really going to go over these unless you need me to. If you need me to go over these, ask me in class. Otherwise, I'm assuming you at least know what they mean. Right? So if I'm comparing two, I'm going to compare negative 10 divided by 2 minus 2. And I'm comparing that to, I'll use a different color. Negative, I'll put it down here. Negative 28 divided by 4 plus 1. All right. So negative 10 divided by 2, that's 5 negative minus 2. I start with negative 5. I'm going to the right twice. So that's negative 7. Negative 28 divided by 4 is 7 negative plus 1. I'm starting at negative 7, going to the right 1 time. So that's negative 6. All right. Now, don't get... so now we're... Oh, before I go there. We're now comparing negative 7 and negative 6. Don't get mistaken here. Don't get confused. Just because 7 is the bigger number doesn't mean it's the bigger value, okay? Remember, the bigger your negative number is, the smaller it actually is. So we're going to put a less than sign. Negative 7 is less than negative 6. Okay. So here, I'm going to try again on another one. Here we have 42 divided by negative 3 plus 9. And then here I have negative 36 divided by 9 minus 2. Cool. So here we have 42 divided by negative 3, which I will work out on the side here. Why can I not? There we go. 3 goes into 4 one time. 4 times. Okay, so the answer here is 14 negative plus 9. I'm starting with 14, going to the right 9 times. So that comes out to negative 5. And if you're not sure, make your own number line, work it out, pause it if you need to, and then see how I got to negative 5. So here we have negative 36 divided by 9. 36 divided by 9 is 4. Negative, positive, so that's a negative, minus 2. I'm starting at negative 4, going to the left, because that's minus a positive, 2 times. So it's negative 6. So I'm comparing negative 5 to negative 6. In this case, negative 5 is greater than negative 6, because negative 5 is the less negative number. All right, so that's it for today. Your homework will be page 52, I believe? No, yes. 52. All right, good luck, and I will see you on Tuesday.